In math lesson 6-8, we are estimating decimal products and quotients. Remember, product is the answer when you multiply. Quotient is the answer when you divide. You will need your whiteboard marker, and your math journal. Would you please number 1 and 2 on your whiteboard? Look at these number sentences. Would you please fill in the blank with a fraction that makes the number sentence true? So if I take a number times 1/3, what could I put in there so my answer would be greater than what I started with, 1/3? Number 2, 5/8. If I multiplied something by 5/8, what could I put in there so that my answer becomes less than 5/8? Well, number 1, I can put in any fraction greater than 1, and I would have an answer that's greater than what I started with. If I just multiply by 1, I would get the same thing. So I could put 1 and 1/4. That's going to give me an answer greater than 1/3. What could I multiply 5/8 by? Remember when we did all of this and we divided? And then we did this and we shaded that. So what could I multiply by 5/8 to get an answer that's smaller than 5/8, smaller than what I started with? Well, any fraction less than 1 would give me an answer that would be less than what I started with. So if I take 5/8 and multiply by 1/4, I end up with an answer less than 5/8. All right, go ahead and wipe off your whiteboard in number 1 to 2 again. Given what I just said, what fraction could I put in number 1 that when I multiply by 3/4, I end up with a fraction that is equal 3/4? What can I multiply by 9/10 that will give me an answer greater than what I started with, 9/10? Well, number 1, any fraction equal to 1/2, right? Because when we multiply a number by 1, we end up with the same number. So what's a fraction, not a whole number? 4/4 is equal to 1, 5/5, 6/6, 12/12. Anything that has a numerator and denominator as the same equals 1/2. And when you multiply by 1, you end up with what you started with. Number 2, what can I multiply 9/10 by to get an answer that's greater than 9/10? Again, any fraction greater than 1/2. So I could say 2 6/7, 3 1/9. Okay, we know that if we multiply 2 4/10 times 1, we'll get 2 4/10. So will 2 4/10 times 1 8/10 be greater than or less than what I started with, 2 4/10? It would be greater than, because anything larger than 1 will give us something greater than what we started with. So when we multiplied a whole number by a fraction less than 1, such as 6 times 2/3, was the product greater than or less than the whole number 6? Well, it is less than. Because if you think of equal groups, the product is less than one group of 6. When we multiplied a whole number by a fraction greater than 1, such as 6 times 3 halves, because 3 halves is greater than 1 whole, was the product greater or less than the whole number? It would be greater than. If you think of equal groups, there will be more than one group of 6. That is more than 6. So, would 2 and 4/10 times 6/10 be greater than 2 and 4/10 or less than 2 and 4/10? Use the information I just shared up here. This is a decimal, but it's still less than 1 whole, so our answer would be less than 2 and 4/10. So if the second factor is less than 1, we know that the product, the answer, will be less than what we started with, the first factor. If the second factor is greater than 1, we know our answer, our product, will be greater than the first factor. If the first factor is less than 1, we know that the answer, or the product, will be less than the second factor. And if the first factor is greater than 1, we know that the answer will be greater than our second factor. So number 1, 2, 3, and 4 on your whiteboard. So if we take do not solve, if we take 12 and 8/10 times 185 and 3/10, will that answer be more or less than what we started with? Well, here's another way. Just think of 12 and 8/10 is close to 10. 185 is closest to 200. Our answer would be close to 2,000. Because we're multiplying by a number greater than 1, we're going to end up with something larger than what we started with. What if we take 896 and 1/10 times 2 and 7/10? Okay, you can think 896 and 1/10 is closest to 900. 2 and 7/10 is closest to 3. 9 times 3 is 27 with 2 zeros behind it. We're going to end up with an answer larger than our first factor because we're multiplying a number greater than 1 whole. How about this one? 4 and 1/10 times 7/10. Well, just think of 4. 4 and 1/10 is closest to 4, and 7/10 is close to 1. So 4 times 1 equals 4. But this is less than 1 whole. So our answer is going to be less than 4 and 1/10. We're going to have less than what we started with. Same thing, 9/10 times 3/10. Our answer is going to be less than what we started with. Take a look at these 3 problems up at the top. 110 times 2 and 8/10. 11 times 28 hundredths. And 11 times 2 and 8/10. What do you notice about the factors in these 3 problems? They have the same digits, right? In the same order. But the decimal point is in a different place. Two and 8/10, 28 hundredths, 2 and 8/10. would you estimate 82 and 6/10 divided by 7? Well, I could just say 80 divided by 8. I can easily do that in my head. What's 80 divided into 8 equal groups? 10 per group. So, where would you put the decimal point if we know our answer should be close to 10? Where would you put the decimal point? Write it on your whiteboard. Well, if I put the decimal point after the 11, that's pretty close to 10. Now, what if I take that same 82 and 6/10, but I'm going to divide it by 7/10? So let's take 80 divided by 1. 80 divided into one group would be 80. Where would I put the decimal point so my answer is closest to 80? I would put it at the end, 118. So we're going to go ahead and move to page 217. Estimating decimal products and quotients. The digits provided in the answer column are correct, but they are missing a decimal point. For each problem, write a number sentence to estimate the product. Means multiply. Quotient means divide. Use your estimate to place a decimal point in the digits provided. An example is done for you. So 12 and 2/10 is closest to 10. 1 and 9/10 closest to 2. 10 times 2 would be 20. I'd have to put my decimal point between the 3 and the 1 to make it closest to 20. Okay. Number 1, 17 and 4/10. Remember, I'm going to make this easy. 20. 97 and 5/10, closest to 100. 2 times 1 is 2 with 3 zeros behind it. Where would I put my decimal point so my answer is closest to 2,000? I'd have to put it here between the 6 and the 5 to get 1,696 and 5/10. Number 2, 83 and 12/100 is closest to 80. 7 and 25/100 closest to 7. 8 times 7 is 56 with 1 0 behind it. Where am I going to put my decimal point so that it is closest to 560? I'm going to put it between the 2 and the 6 to get 602 and 62/100. Number 3, 36/100. Well, that's pretty close to half or 5/10 times. And I'm going to multiply 325 and 5/10. I'm going to make that 300 because I can do that in my head. What is half of 300? Half of $300 is $150. Where would I put my decimal point so my answer is closest to 150? Put it between the 7 and the 1 to get an answer of 117 and 18/100. 4 and 85/100 is closest to 5. 6/10 is closest to 1. 5 times 1 is 5. Where do I put my decimal point so my answer is closest to 5? Between the 2 and the 9, 2 and 91/100. Number 5. 1 and 2/10 is closest to 2. 27 and 3/10 is closest to, let's make it 30 because we want to be able to multiply these all in our head. 2 times 30 is 60. Where am I going to put my decimal point so my answer is closest to 60? Between the 9 and the 1, 49 and 14/100. Number 6, 95 and 76/100. I'm going to make that equal to 100. And again, remember, I'm doing easy so I can do it in my head. 7 and 6/10, I'm just going to make equal to 10. 100 divided by 10 is 10. Where am I going to put my decimal point to make my answer closest to 10? Between the 2 and the 6, 12 and 6/10. Number 7. 515. You know what I'm going to make this equal to? This one might be a little harder for you to see. 490, divided by, and I'm going to make this equal to 70 because I can do 490 divided by 70 in my head. Watch, this 0 cancels out this 0. So 49 divided by 7 is 7. Where am I going to put my decimal point so it's closest to 7? Between the 7 and the 9 to get 7 and 9/10. Number 10, 2 and 76/100 divided by 3 and 68/100. 3 and 3 and 68/100 is closest to 4. 3 divided by 4 is 3/4, right? I have to make this answer less than 1 whole, 75/100. Moving down the page. Number 9. 101 and 8/10. We're going to make that equal to 100. 8/10 is closest to 1. 100 divided by 1. If I had 100 pieces of candy and put them in one group, 100 pieces in that group, where would I put the decimal point so my answer is closest to 100? Between the 7 and the 2 to get 127 and 25/100. Number 10, 1,390 and 72/100. I'm going to call this 1,400. 21 and 73/100. I'm going to call that 20. This 1 0 cancels out that one. Nothing to cancel out the other one. So 14 divided by 2, or 14, half of 14 is 7 with 1 0 behind it. Where would I put my decimal point so my answer is closest to 70? Between the 4 and the 0. All right, let's do one more problem. 4 families held a garage sale and split the proceeds evenly. That's the money they made. They made a total of $1,256.60 at the garage sale. Great garage sale, by the way. Circle the number model that represents the correct amount of money each family earned. Well, here we go. If I took 1,200 and divided it among the 4 families, well, 12 divided by 4 is 3 with 2 zeros behind it. Well, if they each only made $31, 30 times 4 is 120. That doesn't make sense. If they made $1,256.60 and divided it, they couldn't end up with more. And does it even make sense that they each get $3? Each family times 4 families is $12. So the only one that makes sense is B.